Hi, fourth graders. You all did such a wonderful job when you were multiplying fractions. Now we're going to go back to adding fractions, but we're going to be adding fractions with the denominators of 10 and 100. So these are going to be adding different denominators, but in order to start that process, we're going to start with easier numbers. We're going to start with the numbers 10 and 100. And the reason we're talking about adding fractions and focusing on these denominators is because they're going to help us when we get into talking about decimals, which will be in a few days. Because a fraction really is a decimal. It's a piece or a part of one whole. So they just look different. So what we're going to do is I'm going to show you two fractions. Say we have 1/10. Now we see that this is 1 out of 10. Now let's see what that looks like. Right here we have a whole. And we see that the whole is divided into 10 pieces. So you know in the classroom I have those square blocks, and I have the 10 rods, and I have the 100 squares. So this would just be 10 rods that were combined together. So this shows 1 out of 10 strips. So 1/10 is represented by this fraction. Now, what if we have the fraction 80 hundredths? Well, we can see that that's a different denominator. That denominator is 100. And if we take a look right here, we can see that it's the exact same whole that we saw here for 1/10. It's just divided into more pieces. Instead of being divided into 10 pieces, we can see that this is divided into hundreds pieces. And now you could sit there and count every single one of these. 1, 2, 3, 4, 5, all the way until 80. Or if you know that one strip is the same thing as 10, you could just say this is 10, 20, 30, 40, 50, 60, 70, 80. But this would be 80 100ths. Over here, remember, same size, same shape, but here it's just divided into tens. So 1/10. And how that's going to help us is we can use these models and use these fractions into helping us figure out how we can add these fractions even though they have different denominators. And remember, it's also going to help us when we move into decimals. So when we are looking at this here, let's take a look at these two problems right here. Let's take a look at 2 and 3. Well, I want to make this one here match what I have here. So let's take a look and see what that looks like. Right now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have a shape that has 9 out of 10 shaded. Now let's look over here. I already have, let's see, I could sit here and count every single one of those, but I don't need to because I already know that this is 10. So I already have 10, 20 shaded, but I want to try to get to 90 shaded. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, besides my terrible coloring, you can see that these fractions look similar. This one would just be written as 90 100ths, and this one would be written as 9/10. As you can see, it's the same shape. They both have, once again, besides my terrible coloring, the same total amount shaded in. They're just written differently. Now, we can tell that those are equivalent or equal by looking at the model. But don't forget that we also talked about earlier in the year when we were talking about fractions, we talked about how you can make equivalent fractions because what you do to the top, you do to the bottom. So if we did have 9/10 and we were trying to figure out how many would be in the hundredths, we would say, okay, I know 10 times 10 is 100. So what you do to the bottom, you do to the top, or what you do to the top, you do to the bottom. And we know that 9 times 10 is 90. So now I have made those fractions equivalent. The other thing I wanted to talk to you guys about was talking about our new vocabulary words called tenths and hundredths. The reason we're talking about those now is because those are terms that you will be using when referring to decimals. So when you are talking about tenths, you are talking about fractions that are divided into tens. So this would be 1/10. If you're talking about hundredths, you're talking about fractions or numbers that are divided into 100 pieces. You could have 1/100th, you could have 2/100ths, 3/100ths. So all you're really talking about is how many the whole is split up into. Is our whole split up into tenths right now in 10 pieces? Or is it split up into hundredths, 100 pieces? And you can obviously tell by looking at models and diagrams which one's which, because 100 has way more pieces there. So let's talk about how we can add these two numbers together. So let's say I have 5/10, and I want to add it to 2/100ths. Well, you guys know in what we studied so far, the only way we can add those numerators is if the denominators are the same. And as you can see here, the denominators are not the same. So let's figure out how we can make these the same. Well, I could make this 10. I could make this 100 because I know 10 times 10 is 100. So remember, what you do to the bottom or top, you do to the other side. We always have to balance these. So let's take a look to see what this looks like. 5 times 10 is 50. 10 times 10 is 100. And we already had here, we can leave this the same, 2/100ths. So now all we have to do is add. 50 plus 2 is 52. And we're going to leave our denominator the same. You always leave your denominator the same unless you're multiplying fractions, which is what we just did. So let's take a look. Let's take another look. What if we had 20/100ths plus 3/10ths? Okay, well, I know that I can multiply the top and the bottom by 10 so that I can get the denominators the same, for the denominators both to be 100. So just as an easy trick in a different color so you guys can see, remember what you do to the top, you do to the bottom. So now you see that I added those zeros because if I add it to the top, I have to add it to the bottom. Now both of my denominators are the same, so I can add those together. So 20 plus 30 is 50, and we keep our denominator the same. And if you did your math yesterday, you know that 50 over 100 is the same thing as 1/2. It's exactly the same. This way is just broken up. So if we were to look at it here, you would have the same amount. You would have just 5 of these shaded, but you'd have 50 of these, but the same amount would be shaded in both. So let's take a look at page 209 so that when you guys are working on the other pages today in the book, it could be a little reference for you. Don't forget, if you are struggling, you absolutely should use these pages in the book, like page 206, page 207, to help you work through some of these problems. So it says, color the model to show the tenths. So remember, tenths means it's going to be split up into 10 pieces. Then rename the tenths as an equivalent number of hundredths. So here we have 1/10. which is the same as 1 out of 10. So how this model would look is we are just going to shade in one of these bars because that has 10 pieces in it. So another way we can do this is, see, I had 1/10 here, but another way you can solve it when you're converting it to hundreds is just like what I did on the previous page. What you do to the top, you do to the bottom. So if I want to get both of the denominators to equal 100, I'm going to have to multiply the top and the bottom by 10. So remember, the book does put the lines in spots to help you, but sometimes I notice they're just kind of tricky. So if you want to cross these out, you absolutely can, because this is all this is saying. It's saying that you have 1/10 and you want to show it in 100ths. Okay? So remember, my trick is to just multiply both by 10 by adding a 0 to both. So see, we had 100, and now this would be our 10, because what you do to the top, you do to the bottom. Now, if you want to use their lines to show it, you can say, okay, I already had 1/10. 10 times 1 is 10. 10 times 10 is 100. And you can see we did that here. We shaded in 10 out of the 100 boxes that were in that shape. Let's take a look at this one. This one says 50/10, 5/10. I got ahead of myself. Which means 5 out of 10 pieces are shaded. So what we can do is, if we're trying to convert this into hundredths, remember what you do to the top, you do to the bottom. So in order to get this 10 to 100, you have to multiply by 10. So 5/10, if you multiply the top by 10 and you multiply the bottom by 10, we had 5/10. We multiplied both the top and the bottom. 10 times 5 is 50 hundredths. So if you like writing it my way better, that is absolutely great, whatever works best for you. I cut out this middle step right here because I think it can get kind of confusing. So 10 times 10 is 100. 5 times 10 is 50. So now I know that I need to shade 50 of these. I also knew what to do because 5/10 would just be 5 rows of 10. 1 row of 10, 2 rows of 10, 3 rows of 10, 4 rows of 10, 5 rows of 10. So 50 100ths is the same thing as 5/10. Let's look at the next steps. It says rename the tenths as an equivalent fraction. So remember, we're making these tenths equal to the hundredths. And in this case, we're doing it so that we can add. So in this case, we were just showing and modeling. In this case, we're actually going to be doing the adding. So 3/10, that means 3 out of 10 of the whole. 3/10 is equal to how many 42 hundredths? So what I'm going to do is I'm going to write, let's see, I'm going to write 40, 3/10 we have here. And at first it wants you to do what it's equal to. Well, 3/10 is the same thing as 30 100ths. Because if you multiply the top by 10, you have to multiply the bottom by 10. So now that we have 30 100ths, we're going to add that to 42 hundredths. 42 pieces out of 100 in this whole piece. Now that the denominators are the same, we can add. So 30 plus 42 is 72 hundredths. Now we can show that by first, we could color in 3 of these tens shapes. 1, 2, 3. So now we've shaded in 3/10 or 30 hundredths. Check. Now we're going to be shading in 42 hundredths. So you could sit there and count out 42 of these. Or you know that this would be 10 out of 42, 20, 30, 40, and 2 extra. Once again, if these lines are confusing to you, you could write over here 3/10 plus 42 hundredths. And just do the steps I told you earlier. Remember, if you multiply the top by a number, you have to multiply the bottom by that as well. So if we multiply both by 10, 100 times 10 is 100, 30 times 10 is 30, and then we just add here. So when you're doing your work today and these lines are confusing you, but you understand what the question's asking, you can ignore those lines. I wanted to help you solve the way that it's best for you. All right, last one, number 4. We have 20 hundredths, okay, plus 11 tenths. And the reason here they chose to have us do the tenths first, just like we did the tenths here, is because that's the one that we're going to be converting. Remember, we're going to go up to 100 and multiply by 10, and so this is the one we have to change. 20 hundredths is going to stay the same because it already has the denominator we're looking for. So if we have here 20 hundredths plus 11 tenths. All right, so 11 tenths is the same thing as 110 100ths. And that is an improper fraction, and that's absolutely okay. That just means it's more than 1. So how did we get there? We multiplied the top. I'll try to do it in a different color. We multiplied the top by 10 and the bottom by 10. 11 times 10 is 110. 10 times 10 is 100. So let's rewrite that here. We had 20 hundredths. Now we have 110 hundredths. So let's add those together. 110 plus 20 is 130. So we need to shade in 130 of these bad boys. So I already know that this is a 100ths cube, or it's on a flat surface here. So I'm going to color the whole thing in because that is 100 cubes shaded. Okay, so this is one whole. Now we are at 100 cubes, but I need to shade in 130 cubes. So once again, I could either sit here and count all of these out, 30, but I know that this is 10, so why am I going to do that? I'm going to color in 10, 20, 30. So if all of these, if the book is driving you nuts, I just want to make sure and reiterate that you can solve it any way you want. You can ignore the lines. Let's just do one more problem together without using the book to make sure that you understand what you're working on. So let's say I have 2 tenths plus 30 hundredths. Oops, sorry. Okay. 2 tenths. I know that this is 2 out of 10. So if we were to have a whole candy bar, 2 out of 10 of those pieces is what we're talking about. Now, 30 hundredths. I'm going to take 30, and as we can see, hundredths, we are going to put that over 100. This is 30 pieces out of 100. Now, let's take a look at how we can add these. So remember, we need our denominators to be the same in order to add them easily. So what you do to the top, you do to the bottom. We need to get to 100. So in order to do that, we're going to multiply the top by 10. And what you do to the top, you do to the bottom. So 2 times 10 is 20. Sorry, let's get this focused for you. And 10 times 10 is 100. We can leave 30 hundredths the same. So 20 plus 30 is 50, and you leave your denominator the same. I must really like that number because once again we have 1/2. Sorry. So please let me know if you have any questions today. The most important things to remember are to add easily. Your denominators have to be the same. Remember that what you do to the top, you do to the bottom. Have a great day, and I hope to see you all later. Bye.